Hello everybody, welcome to the demo session on Big Data Analytics. In this session, we will be doing an introduction to Big Data, and we will be also understanding some of the application areas in Big Data and why is it important for everybody in the technology space to understand about this technology, because it is changing the way people are working, people are behaving, and technology trends are going. So first, let me talk about the TACT, which is providing this different technology trainings. TACT is a leading emerging technologies training provider, and it has a lot of award-winning trainings which it is providing. There are over 40 offices, and it has trained over 10,000 professionals in the corporate world. TACT has about 350 plus clients across the globe, and it is also among us the top 3 vendors for 75% of its clientele. And it has the best-in-class trainings on emerging technologies. These are some of the TACT awards and affiliations. It has been recognized as the top emerging technologies company, and a lot of trainings it has provided. So some of the worthwhile trainings are Big Data Developer, and we have top cloud training provider, top IoT training provider, and top World HRD Congress award is given to them. It is also affiliated with a lot of partners like Mapr, IBM, Google, and so on for providing their trainings. These are our few proud clients, and as you see, there are a wide variety of clients with which TACT has collaborations with, and a lot of these clients are in the area of this digital transformation, where they wanted to understand and get their employees trained on these digital technologies. So anywhere coming from big data, from cloud, from IoT, from from DevOps. So all these kind of trainings are provided, and they are kind of getting benefit of it. So our global footprint is in many countries. So these are a couple of notable countries which we are present in, and it is kind of multinational. So you have multi-country presence for providing trainings. Let us quickly talk about myself. My name is Sitaram, and I have 12 years of experience in IT, software development, and solution designing, and over 5 years of experience in big data and related technologies. I work as a big data architect for a multinational company and also a freelance trainer for TACT. My hobbies involved in running, tracking, building machine learning models, and technical interests are deep learning, conversational bots, and artificial intelligence and scalable systems. So scalable systems is where a lot of big data work happens. So let us understand the motivation for this demo talk. The motivation for this talk is to understand the trends and where they are heading. So as you see, this is taken from Indeed.com, which is one of the primary job portal in United States. So as you see that there are these trending technologies which like Java, which is having a downtrend, and also as you see COBOL, which is one of the legacy technology, which is also having a major downtrend. And here I've used the word Hadoop, but there are a lot of ecosystem tools which are part of Hadoop right now, which are also seeing this uptrend in the job market. So it is very, very important for everybody to get this knowledge about what is big data, what is Hadoop, how are these technologies being used in the data transformation, data processing, and analysis. So our talk today will be understanding about all these areas and kind of touching base about these areas and understanding why these are important. First, let us understand about data in a minute. So it is said that as statistics that there are 72 hours of YouTube video uploaded every minute, 2.5 million pieces of content being posted in Facebook every minute, and 26.4 thousand posts are posted in Yelp. And out of that, you also have stats like 204 million emails are sent every minute, and 48,000 apps are downloaded by Apple users every minute. So because these stats are by every minute, we are seeing that a lot of traction is happening in the data world. A lot of applications are developed, a lot of interactions are happening, and world has gone social. Because of all these interactions are happening, it is very important for the enterprises who are tagged to these interactions kind of get the data from those interactions and mine the information so that they get insights of what is happening. Slowly it has started from these web companies where the web companies are very important doing this web scale data processing, like Facebook, Google, Twitter, LinkedIn, and so on, and they are doing this work. But slowly the trend change where not only the web companies are working on this big data, but also the enterprise companies are also working on this big data. They also realize the worth of this traction in data, a lot of creation of data, and they really wanted to get the insights of the customers. So what happened was, because the data was increasing so much in your traditional old technologies, what we used to do in enterprises is we used to have one single machine where you used to dump more data into the machine. And if the machine was not able to store the data, then what we used to do is we have to bump up the machine with more amount of RAM and disk space. So because you have more amount of RAM and disk space, the machine was again able to store more amount of data. Likewise, the process was continuing, and this was called as scale up processing, where the scale up means that as in when you get more data, you kind of increase the amount of RAM and memory so that you make it bulkier. So that was traditional way of doing data processing. But in this world of big data, where we have seen every minute a lot of data is coming in and injecting into the systems, it doesn't work. As you are seeing that this Pac-Man, people are trying to fit to this Pac-Man, and it is kind of bulging and bulging. That is the case with the legacy systems. A lot of legacy databases are kind of becoming bulkier and bulkier, and it becomes a high risk for enterprises because they can't depend upon one single machines or one single server or database. So there is a very real need of technologies which can kind of use a distributed paradigm, where instead of storing data in one single machine, we can store data in multiple machines. Let us see. I would like to give a small example of a king and a minister. So we'll take a few minutes for understanding an example, so which will give us real understanding about how this big data will help by doing a distributed processing. So this is a king of a kingdom, and this guy is the minister of the king. And one day he wakes up in the morning and he gets this weird doubt that how many people stay in his kingdom. So he calls up the minister and asks like, how many people stay in my kingdom? And the minister was a loyal guy, so he kind of obeys all the orders by the king, and then he says that I will get the count of the kingdom and then come back to you, master. So what the minister does is he goes to the North Kingdom and goes to every house and kind of get the details about house, like how many people are staying in the kingdom and all of that. So he takes 10 days for getting the counts of the entire North Kingdom, and then comes back with a count saying that there are 10,000 people staying in the North Kingdom. King was really upset because he has already taken 10 days for getting this small information. And one other thing he was not happy is because the minister did not utilize any of his resources. So the resources was their soldiers, their horses, and then carts, and so on. So what he says is, you took 10 days, and what a shame. Go and utilize my soldiers and kind of get the population of South Kingdom. So now the minister thinks that, how can I utilize all these soldiers at the same time and then get the population of the South Kingdom. So what the minister does is he groups the soldiers into individual groups, and then ask an individual group to go to a particular street and get the count. And what is the group is responsible is it goes and gets the count of that particular area and gives back the information to the minister. So what happens, within 10 minutes he was able to get the count of the entire South Kingdom. So he get accounts like 15,000 and he says there are 15,000 people in the South Kingdom master. So now the king was really happy. So he says, see, if you have utilized everyone, it just took 10 minutes. So that was what king was saying. So if you kind of think of the story and understand the data problem we have, so our data is kind of very huge in the same lines of the kingdom. And every record has to be accessed in our data as well, because we need to understand whether there is a value in the data or not. So that is the same problem which this minister is facing, where he has to go to every house and understand the counts of people staying in that house. And the third, like, the minister is a very powerful guy. He might have one words, but it is not working because it is taking time. There is a lag delay in getting the counts of the people. So that is what happens in the big data world as well, where your high performance computing machines will not work. Even if they work, they are doing a sequential processing and they will take some time for getting your analysis. So what worked is your distributed processing. When you distribute your resources, your people, and then they go and get the count of the population for an individual street, and the entire counts are percolated back to your minister, so that minister gets the information pretty quickly. So this is what is happening in the big data world also. So the same architecture is applied, and it is one of the popular architecture called as Hadoop, which we will be discussing throughout the course. And what it does is it has this master slave configuration where your slave machines are working on your data and they compute some output of the data and they percolate back the results to your master, so that master aggregates all the data and then finally gives back the result. We will look more while we do the course, but let us understand what is the definition of a big data. So definition of the big data, which says is, it is the realization of greater business intelligence for storing, processing, and analyzing data, which was previously ignored by the limitations of traditional database management technology. So what does that mean? I have highlighted three of important ones. So it says that how we store your data, and how we process our data, and how we analyze our data in the world, which was different from the way your traditional database management technologies were doing. So there was some limitations in the traditional database management technologies, like I can't scale up the machine more than the prescribed capacity. I can't process the data in parallel. I can't process your data in much more quicker way. So these are all some of the limitations. So all these limitations will be addressed by big data. And the way it does is by storing your data in multiple systems, by processing the data in multiple systems, and then once we process the data, you analyze the data about getting insights. That is what we will be covering. So most of the course will cover about, how do you store it, how do you process it, and how do you analyze it. Let us understand some of the characteristics of big data. So like any other object, big data also has some characteristics. So first and foremost important one is volume. The hugeness in the data, which kind of gives its name as big data, is the volume. Like how much of data is there from all the sources. So much of data is there. So that amount of data, which comprises of all these parts of data, will be treated as the first characteristic, which is called as volume. That is sheerly the hugeness in the data. Second one is your velocity. Velocity is very important because in the world of big data and in the real-time data, we should catch the speed of which the data is generated, because the data is generated at a tremendous speed. And if you don't catch the data in the tremendous speed, it will be like a loss of opportunity, right? So it could be happening like there could be some travel bookings happening, and there could be some customer transaction happening, and if you don't analyze the data in real time, what happens is you will be losing that customer. So second angle is called as the speed at which the data is getting generated, and that is called as velocity. And the speed of the data getting generated is important because our big data architectures or algorithms should also match the speed of which data, so that your business can be benefited. So that is the second angle. The first angle was volume, which tells about the hugeness of the data, and volume is important because we need to understand about the architectures where we can store the data in multiple distributed databases, and so that this huge amount of volume could be stored. And the second one is your velocity, which tells about the speed at which the data is generated, so that we need to understand about if the speed of the data is generated, how we will process the speed in data so that we can do a real-time processing so that we can catch it. Third important characteristic is called as variety. So variety is where it says that the data is generated in multiple forms. So in olden days, we used to have just row column format data where we store them in the tables. But in these days, we don't have this row column format data. We just have data in its raw form and probably in a different form. For example, you have data in text format, you have data as videos, you have data as audios, you have data as MRI scans, you have data as X-ray images, so you have data as heat sensors, you have data from different temperature sensor or wind sensor or any other sensors. So as you're seeing, the data is no longer in your row column format. So it is having a different pattern or a different way altogether, a format altogether. So it is important for big data analysts that how these different varieties of data could be stored on the same platform, and how we can analyze the data despite of the variety in its nature. Right? So that is very, very important for big data analysts. So in the course, what we will do is we'll understand that how these different formats are data analyzed, how these different formats of data are injected, and how these different formats of data could be viewed as an insights. The fourth and last V is called as veracity. Veracity is also very important. So what does veracity say is the trustworthiness of data, which makes it trustworthy, so that we can depend on the data and so on. So what does the trustworthiness and dependence mean? So if at all you can take an example that you are as an analyst, you want to do some analysis on Twitter data, and then you take a lot of data from Twitter, and then you're getting this volume, velocity, and variety, because Twitter has a huge amount of data, which Twitter has the speed at which the data is processing, and Twitter has multiple formats also, like text and YouTube, text and videos and audios. So if you take the data and directly analyze it, one thing you might not get accurate results is because there could be a bias in the tweets. For example, you are analyzing some political outcomes of your tweets, trying to understand the sentiments of the customers. If you take the data for a single sample of your Twitter audience, it might not generalize to the entire public. So before taking your data, you should ensure that whether the data has any duplicate records, whether the data is coming from a single source, whether the data is generalized to a generalizable to a different public, and whether the data is not having any duplicacy in data, whether corrupt records are there. So certain kinds of analysis has to be done before you do any work on the big data, and that angle is called as veracity. Right? The thing which says that the data is trustworthy, the data does not have any ambiguity and all, that is called as veracity. And as a big data analyst, we should understand that what are the mechanisms we use for understanding the veracity of your data, so that you do right decisions, right? Because you do not take the data which is having some bias or skewness, so which can give you obscure results. So you should ensure that there is the data is generalizable, data does not have any bias, this data is trustworthy, so that you can get better results. So through our course, we will understand about how to understand the veracity of the core, or veracity of your data, and then process on it. So these are the four different V's we call as, which are characteristics of big data. Let us understand some of the application areas of big data, which has really made it revolutionize the way the data transformations are happening. The first and foremost is your social media analytics. Social media analytics is where a large portion of big data processing initially started. So it started with web processing of your Google by indexing your web pages. Then Yahoo took it. Then you have YouTube, then Facebook, Twitter, and Instagram, and all these kind of applications. What they are trying to do is they are trying to get huge amount of data which is getting generated, and of course it is in different forms, right? It is in text, it is in videos, it is in audios, so, and it is in pictures. So all these kinds of formats of data is getting injected into this machine, injected into these applications, and they really have to go away from your traditional way of data processing. So they can't use your regular RDBMS database to store all these kind of things and still do analysis. So that's the reason it was really important for them to do this analysis by inventing different architectures which can store data, process data, and analyze data. And that kind of gave a lot of foundation for a lot of enterprises. So applications like Hadoop and Spark and Storm and HBase and Hive and so on. So these are some of the names of the applications which big data uses. So all these kind of applications were developed because of these companies, which has this huge problem of processing data in multiple formats, multiple sizes, and so on, so that your data processing would be done. So after these web companies or social media companies have reaped out benefits of using non-traditional systems like NoSQL systems, big data systems, distributed file systems, then enterprises have realized that this is of something good, and they can also use for their purpose. So one of the very important applications which enterprises has initially started using big data is predictive analytics. So what is predictive analytics is in your enterprises you have a lot of transactional data. So transactional data were about a product, about a customer. So all this transactional data could be used and could be stored in big data, and then from that we can get insights of a customer or a product or a sale. That sale is in a predictive nature, so that depending upon the past data we can get some insights of what is going to happen in the future. So we can get some patterns in which the data processing is happening, so that we can then kind of generalize it to a future prediction. So many of the companies, primarily the banks and customer facing companies and retail and manufacturing, and all of these companies really had taken predictive analytics at the next level to take big data and then process their data and then kind of get insights of the data. And it was only possible because now they are not only looking at your transactional data, they're also combining the transactional data with your customer feedbacks, with your data from your web logs, data from your click streams. So all these kinds of data are kind of combined, which were previously in different silos, are now combined together, so that we can get a holistic picture about what a customer is thinking, what a product is, what is the product life cycle, how the sales are happening, and so on. So that was a very important thing. So as big data engineers, we really need to understand about how these analytics is happening, like how the data is ingested, how the different silos are kind of merged together, and how we can give a holistic view of an application, and then how we can find patterns. So these are all very important questions as a big data analyst to answer. So throughout our course, we will be understanding those in very fine detail. Next application is fraud and intruder detection. This is very important. So apart from your predictive analytics, this was very important for banks and financial institutions. So this is a kind of thing where we call as anomaly detection. So anomaly detection is where you try to find out some transactions which are different from the crowd. So most of the transactions will happen in the same way, but there are some transactions which are kind of away from the actual crowd. So those are kind of termed to be either fraudulent or anomalies, so that you can kind of find out those transactions and then based on based on those transactions act upon it. So many of the financial companies, what they do is they kind of identify this fraudulent transaction or kind of transactions which can be some of different nature, and based on that they take some decisions by their own. So some of the lighter decisions would be sending out an email to the customer for understanding whether the transaction was done by him or her, or also blocking their credit cards or debit cards because a transaction happened in a different country in a completely different country rather than the country which the credit card user is there, right? So such kind of decisions will be taken by the companies, financial companies, which kind of block the fraud to be happening. So a lot of fraud things happen in financial institutions primarily, and also in telecom and manufacturing and other domains. But we'll understand throughout this course like how these, with very real-time examples, that how these fraud transactions could be identified, how we can take data of these fraudulent transactions, and then kind of detect these anomalies. Next important one is sentiment analysis. This is one other important area where big data is used hugely, because a lot of this data and patterns which we see is kind of generated in the social media, and it is really important for customers, customer companies to understand how the customers are behaving. So whether they are happy about their products, or whether they are sad, or whether they don't have any no preference bias, I mean, they don't have any feelings about the products. So this is very important in the age of this e-commerce thing, where a lot of selling is happening through these e-commerce portals. So they also have these kind of reviews and feedback mechanism, voice of the customers. So all this data is generated, and all this data is collected, and sentiment analysis is done on that data. So as you see, these reviews and all of this is unstructured data. You don't have a pattern in it, but we need to really understand the pattern in the data, understand what are the different entities in the reviews. For example, somebody giving a review about a mobile phone saying that the build quality is absolutely brilliant of the mobile phone, the voice clarity is good, the sound quality is good, but the camera is awful. For example, if somebody gives this kind of review, this is kind of a mixed bag, because there are a couple of things which are positive, couple of things which are negative. But from a company perspective, we really need to iron out like what are the things which are positive and what are the things which are negative, and how negative they are. So we can do something called as entity resolution to identify what are the entities. So entities could be build quality, camera, voice quality, then touch and feel. So these could be your entities, and from these entities we will identify that build quality and then voice and touch and feel are brilliant, but your camera is not up to the mark. So companies who are kind of producing these mobile phones can then go back to their product departments and then understand that they have to improve the camera quality, or probably a couple of years before there were no front facing cameras, and when this selfie revolution came into picture, people really understood that people wanted to buy cameras who are also having front facing cameras. So then they introduced front facing cameras. So like that, based on the reviews of the customers, we get a lot of insights. So as a big data engineer, we really need to understand how a text could be analyzed, right? So text is a primarily unstructured data. A huge amount of unstructured data is there. So how this unstructured data could be curated, how this unstructured data could be analyzed, and then taken value out of it. So that is very important, and through the course we will be understanding like how analysis could be done on textual data. Next important application is your classification and clustering. So this is an application where you're trying to segment your data into multiple pieces or multiple pieces or areas, right? And this is very important in the face of customer segmentation, product segmentation, and so on. and very widely used in your retail and e-commerce industries, right? So we wanted to understand, like, what are the customers who are spending more, what are the customers who are spending less, and how to segment them into multiple areas, so that you kind of treat these different segments differently. So if you have very high spending customers, frequently coming customers, you can probably provide them some loyalty points so that they visit your shop again and again. So these kind of applications are there in big data, where you have a lot of clustering and then classification happening. Classification is where the group which the data belongs to, where clustering is like mostly unsupervised, where you do not know which group does this data belong. So you randomly create the groups and then kind of understand the features of it, and then basically group them together. So in big data, we will be doing some real-time projects in this big data course, which are very much aligned with how do you do customer classification, how do you do customer clustering, and then how do you group them into multiple groups, which are like high spending, low spending, and so on, based on the data. So that is what we will be covering in the course. One other very interesting area is recommendation engines. Recommendation engines is kind of understanding the data inside your data and trying to group them based on the associations they have. For example, in this diagram, in this presentation, as you see, there are some books which are recommended together. And this is because people who are buying the book number 1 are also trying to buy the book number 2 and 3 and so on. So it kind of makes that you kind of give them as a combo pack, and saying that people who are interested in this is also interested in this, right? So all these things is called as done in something called as association rule mining, where you try to find the associations between the products, and then based on the associations and frequent buying patterns, you try to recommend those to the people who have bought the initial product. So it's a very fascinating area, very interesting area in the primarily in the retail space and e-commerce space, where a lot of companies are using this recommender systems to try to recommend things which could be of interest of people who are buying the initial things. So during the course, we'll do some projects which kind of use a lot of retail data, where we'll try to find out patterns in it, and then try to find out associations and the products which could be sold together, right? So we can kind of make a combos or do recommendations on the products. Next interesting area is your Internet of Things, which is an area where you are trying to understand. We are having different devices connected onto the different devices connected over a Wi-Fi, and all these devices are connected with small sensors which measure the data about the device. For example, you can take a workshop where you're having all these lathe machines, and these lathe machines have the are responsible for cutting your iron, for building your cars or products and so on. So these lathe machines have a lot of other sensors which are connected. For example, sensor for your temperature, sensor for your viscosity of the lubricant, sensors for your vibration of your lathe spindle. So all these sensors are connected, and this collected data is pushed to your big data clusters, where all this data is ingested in real time. And once the data is ingested in real time, you have to collect the data in real time, and based on that, you have to do some preventive maintenance. You have to do a prediction saying that whether this machine will go bad in the coming weeks. And this is very important, because a lot of productivity will be lost if you don't estimate the loss of your machine well in advance. Because if the machine goes down and your shop floor is stopped because of one machine dependency, then your productivity will go at toss. So there are a lot of new applications which are coming in this area, which are called as preventive maintenance, where you try to understand the parameters well in advance, and you do analysis on your big data which you have collected from all these sensors, and then you try to understand that what is the best time this machine can go bad. Whether it will go bad or not is the first question. So that will be answered, and if it goes bad, then we'll try to also estimate, like, when it could go bad, depending on the previous data, right? We have a lot of data from all these devices previously, which will tell that these machines go bad or not, and based on that we will try to analyze. So very interesting areas are there in this space as well. The next interesting area is your personalized medicine. Personalized medicine is very important for human race, because even in medicine, right, a lot of things happen very generically, right? So you are a person and you are out with fever, then you will be given Crocin or Advil or some other kind of drug, and it will work or do not work. But if it works, then it is fine. If it doesn't work, then you will be asked for doing more tests, right? So primarily the way medicine industry is working, or hospital industries are working, are not generalized, are kind of generalized. They are not personalized for individual people. So now in major hospitals, what we have is we are having something called as EMRs, which are like electronic medical records. So those are the records of people, and those are records of what is your previous history of medicines, what was the previous history of diseases, and what was your immunity level, what worked with your body conditions. For example, body conditions like what is your age, what is your height, what is your weight, what is your fitness level, and all these things. So these are much more personalized. So all these records are captured by these hospitals, and now with the invent of big data, all these records could be stored on big data systems, and also we can kind of personalize to customers. So if at all we have seen that so and so build person with so and so age and so gender and so and so fitness level is affected with common flu, then we can suggest a personalized medicine to him or her based on the previous pattern of data which we have seen, right? And that kind of generalization is happening because now the data is collected from all these different hospitals into a centralized big data clusters. So you see that there are a lot of big chains of hospitals, so they are in multiple cities. So they have their data centers on multiple cities, so all this data is pushed onto your big data clusters, and then on the big data clusters we could write generalized algorithms which can find these patterns, so that we can give some personalized medicines to the customers. So this is also a very interesting area in the healthcare industry, and it is giving a lot of traction in the area of big data. So what we have seen so far is we have understood a lot of applications in this area, and it is also giving us the sense of thing that this is the technology which will live for the future. And because we are in the transformation stage, that we have to enable us to understand these new technologies so that we are ahead of the crowd. And TACT provides that curriculum which kind of give you both theoretical as well as practical examples about how to deal with big data, not just giving some theoretical things that, okay, this is the word count example, this is how it works, and so on. We are much more devoted for giving a lot of practical examples, so that people who come and take our trainings will benefit and really get it into production. So people who are just out of the training are now kind of deployed in projects, and they can directly work in the projects with all these new technology areas we are covering. So just to give a brief about what we are going to learn. So we'll be learning about the Hadoop architecture, which is very foundational for the big data. So in the initial slides, we were understanding that big data comprises of storing, processing, and analyzing. The storage happens in the Hadoop architecture. So Hadoop is a distributed architecture where you have multiple machines in the part of a cluster. So you store the data in the multiple machines, and this architecture helps us to ensure that the data is fault tolerant, it does not lose the data, and we have multiple copies of data available, and so on. So in the course, we'll be deep diving into the Hadoop architecture, understand the details of it, and understand how the storage happens from the big data front. We'll also understand about a programming paradigm called as MapReduce, where MapReduce is the paradigm where you take the data from Hadoop architecture, divides into multiple maps and reduce, and do a parallel processing. Versions of MapReduce is also used, like we will use tools like Hive. We'll cover the Hadoop ecosystem, which will use tools like Hive, Pig, data ingestion tools like Scoop and Flume, real-time data processing engines like Spark, Spark SQL, Spark ML for doing machine learning, and we also understand the tools like how do you do low latent data processing using HBase, and how do you do workforce scheduling using Woozy, and so on and so forth. Some of the ecosystem tools we are covering, but there are a lot of practical examples which are dealt with these ecosystem tools, which combine all these things, right from the data ingestion till the visualization of the data. So you do data ingestion, data processing or data cleaning, and then do data analysis, and then finally you do data visualization. So we'll do a lot of end-to-end connectivity things, so that when you go into the projects, you will really understand that how the data is coming, how the data could be merged from silos, how you can analyze the data, and how you can finally give the results. And last, we will also do a lot of hands-on practice. We will do a lot of programming. You will be provided a cluster so that you can do programming by your own if you do not have any machines. But we'll also be hand-holding you, like how to install Hadoop, how do you configure that, how do you process the data, how do you ingest the data. So all those things could be done in much more practical way. We will also provide a lot of tips and tricks for getting certifications from a lot of industry leaders in the area of Hadoop. Of course, Collaborate Act also provides certification at end of this course, so that you can use that as a valid credentials for whatever you have learned, and then you can use it in your prospective employer. Apart from your regular certification, you'll also get a lot of knowledge from a practical perspective to implement and also implement those concepts in your project area, and also cracking the certifications which are like from general vendor providers like Cloudera, MapR, Hortonworks, and so on. So I hope this demo session gave you a very good understanding about what is big data, what are the characteristics of big data, what are the different applications areas of a big data, and how is it important for us to understand those application areas, and where this tech is going. And also in the end, we also kind of got a gist about what we are going to cover in the course. So this is a really exciting course, and I am also excited to teach you guys on this. And I hope that you kind of register the course and enjoy the ride. Thank you very much, and I hope you have a nice day. Enjoy.